Hello everyone, welcome to this study whereby we are considering a rotation center 0, and a general angle theta. We are considering a general angle which is angle theta. So we want now to look at a rotation about the center 0, in a general, and then we replace the general angle with the angle of 90 degrees, that of 180 degrees, that of 270 degrees, and that of 360 degrees. So we need to obtain the coordinate of I prime, that is the coordinate along the x-axis and the coordinate along the y-axis, and that of j prime. So to do that, we are going to make use of SOHCAHTOA. So we'll make use of SOHCAHTOA. So we need to get the coordinate of I prime. So the x coordinate of I is ON. So ON. To do that, we are going to get the cos of theta. Cos theta will be given by adjacent, which is ON, divided by hypotenuse, which is now these triangles here, triangle ON I prime as a radius of 1 unit, and also this other triangle OMJ as a radius of 1 unit. So ON divided by 1, meaning that our ON is equal to cos of theta. Then sine of theta will be given by opposite. Opposite is ni prime, or I prime n, divided by 1, meaning that our I prime n is equal to sine of theta. So we have obtained the coordinate of x-axis and the coordinate of y-axis. So the coordinate of I prime here, we can now write our coordinate here in terms of it will be cos theta, comma, sine of theta, because we have obtained that ON is cos theta here, and we have obtained our I prime n to be equal to sine of theta. So that is the coordinate. Next, we want now to get the x coordinate of j prime. J prime is here. So clearly you can see our j prime, it is this distance here. That distance, that is our j prime. And when you look at it keenly, it is a distance along the y-axis. Along the x-axis, it is distance OM, and along the y-axis, it is distance M. It is distance MJ. So that is the case. So the x coordinate of J is OM. X coordinate of J prime is OM. So I can write it here this way. Sine of theta is equal to opposite. Our opposite is OM divided by hypotenuse, which is 1, meaning that our OM is equal to sine theta. Now, when you consider OM is negative of ON, meaning that OM will be equal to, so our OM will be equal to negative of sine theta. Negative of sine theta because it is in this side. This side here on the triangle, it is negative. It is negative. So negative sine of theta. Then the y coordinate of j is mj up here, mj there. So cos theta will be given by mj divided by hypotenuse, which is equal to 1. Meaning that our mj, we multiply by 1 both sides, is equal to cos of theta. Cos of theta there. So now we can write our coordinate. We can write our coordinate of j prime here. So let me write it down here. J prime, coordinate of j prime will be given by, you start with that of the, along the, always you start with the date here to be negative sine theta. Negative sine theta. Here, negative sine theta, comma, cos theta. Cos theta. So that is what we obtain here. J here, x-axis here we have found it is negative sine theta. Along the y-axis we have found it to be cos theta because this is the opposite. This is the adjacent. Now the matrix of rotation. The matrix of rotation theta center 0, 0 is, so the matrix of rotation of angle theta center 0, 0 will be given by the first one here, which we obtain here, which we obtain as cos theta sine theta, together with this other one which we have obtained here as negative sine theta and cos theta. So we write it here. So it is cos theta sine theta, negative sine theta, then cos theta. So that is the matrix of rotation of angle theta. That is the matrix of rotation of angle theta center 0, 0 is given by cos theta sine theta. This is for I, as we have found here. For I, for j, we have found it to be negative sine theta. So it will be given by cos theta sine theta. That of I, always you write that of y first, cos theta sine theta, but you write in column form, given by that of j prime, which is negative sine theta, cos theta, and you write them in column form as shown here. So in the next video tutorial, I will show you now how we can get the corresponding matrix of transformation using this general matrix, whereby now we are going to use rotation center 0, 0. We are going to find that of 90 degrees in the next video tutorial, 90 degrees, that of 270 degrees, and that of 360 degrees, simply by replacing theta with these angles, angle of 90 to 270, 360, and of course even that of angle of 180 degrees. That is what we are going to do, and we are going to see it to be very, very, very simple once you know this general form. The rotation center 0, 0. So rotation center 0, 0, and the angle shown here, of course, anti-clockwise direction. It is the one we are going to consider. So bye bye. See you in the next video tutorial.